What's up everybody, this is John with John Fair Innovations bringing you another math video. Now today I'm bringing you an arithmetic problem that I found on the internet which I found really fascinating, and it kind of highlights how ridiculous and complicated math may seem, but it's actually not half as bad as when you break it down. Now before I get to the video, if you enjoy it, do make sure you hit that thumbs up button, leave a comment on maybe another math topic you'd like me to tackle. And if you really enjoy the video, do make sure you hit that subscribe button so you can stay up to date for all the videos as they come out. Now I've changed the numbers slightly, but the concept of this problem is still the same. And what we're going to be using is quite a few different mathematic techniques in order to solve this fraction. So the problem that we're solving today is an arithmetic one that I've got right next to me, which is 4 to the power of 6 plus 4 to the power of 6 plus 4 to the power of 6 plus 4 to the power of 6 all divided by 4. And it seems really complicated, but we can actually break this down and we don't actually need a calculator in order to solve. Crazy, right? So firstly, what we're going to do is we're going to use fraction rules. Now when we're adding and subtracting fractions, when we want to simplify it, we simply find the common denominator. But in this case, what I'm going to do is I'm actually going to do the opposite. I'm actually going to break them up to make them a lot simpler for me. And because of this, because they're all adding one another on the top, I know that they have to share the same denominator. Otherwise they couldn't be added together like this. So I can split this fraction up into 4 smaller fractions. So I've got 4 to the power of 6 divided by 4, plus 4 to the power of 6 divided by 4, plus 4 to the power of 6 divided by 4, plus 4 to the power of 6 divided by 4. And so now we've got smaller fractions that we can work with. Now the next thing we're going to be using is indices rules, like power of rules. And when we have power ofs and they have the same base, so in this case they have the same base, which is 4, when they're dividing, we actually take the indices, the power ofs, so the little numbers above them, and we subtract them. So we follow this rule of, like, if you wanted to have it in terms of a, for example. So you could have a to the power of m divided by a to the power of n is the same as saying a to the power of m minus n. Now, in this case, we've both got them as to the base of 4. And what we're doing is we've got a power of 6. And on the bottom, because we don't actually have a number above it, this actually means 1. We don't bother writing ones often because ones, when we're multiplying, when we're powering, they don't actually change the number. So there's no real point to put that number. But if we look at this, this is actually 4 to the power of 6 divided by 4 to the power of 1. And using this division rule of power ofs, we simply subtract the two top numbers. So 4 to the power of 6 divided by 4 is the same as 4 to the power of 6 minus 1, which equals 4 to the power of 5. So I do this for all 4 fractions that I have. So now my equation is going to read as 4 to the power of 5 plus 4 to the power of 5 plus 4 to the power of 5 plus 4 to the power of 5. Now what we're going to do is we're going to factorize. So can we find a term that we're multiplying all these by that are the same? Well, they're all 4 to the power of 5, aren't they? And remember what I said before, if you have something and it multiplies by 1, for example, it doesn't change. So these are all, you could say that these are all 4 to the power of 5 multiplied by 1. So I could factorize out the 4 to the power of 5, and that's going to leave me now with 4 to the power of 5 outside of the bracket 1 plus 1 plus 1 plus 1. So I have a positive 1 for every time I had a 4 to the power of 5. Now what we're going to do is we're going to simplify this. So 1 plus 1 plus 1 plus 1 is the same as 4. So now we've got 4 to the power of 5 outside of the bracket of 4. And now we are going to use multiplication power of rules. So when we're multiplying power ofs, we actually add our indices, our power ofs. So if you had, for example, a to the power of m multiplied by a to the power of n, because they have the same base, we simply add the two indices. So that would read as a to the power of m plus n. Again, in this case, we have power ofs of, we have bases of 4, and we have a power of 5 and 1. So these multiplying one another, so 4 to the power of 5 multiplied by 4 to the power of 1, is the same as saying 4 to the power of 5 plus 1, which ends up giving you 4 to the power of 6, which seems a bit weird because when we first started, we had all these 4 to the power of 6s on the numerator of our fraction. But if you wanted to calculate this, so say if you wanted to work each of these out, so 4 to the power of 6 is the same as saying 4 times 4 times 4 times 4 times 4 times 4. And you plug this into a calculator or you work this out by hand, that's going to give you 4,096. Now, if you added these together, so 4,096 plus 4,096 plus 4,096 plus 4,096, that would leave you with 16,384. And then when you divide this by 4, you would be left with 4,096, which we said earlier was exactly the same as 4 to the power of 6. So it's kind of cool that you end up with 4 to the power of 6 when you had all these 4 to the power of 6s on the numerator of this fraction. So I thought this was something cool that I'd show you, just like that, you know, mathematics can seem a bit silly, that you would have this problem where you have all these 4 to the power of 6s adding one another, and you would end up with simply 4 to the power of 6 as your answer. But thank you so much. Hopefully you enjoyed that. Do practice these sort of problems yourself, trying to manipulate the equations, breaking down fractions, you know, changing, factorizing, that sort of stuff, in order for you to manipulate the problem to get it how you want it. Because that's how we do when we're dealing with algebra, when we're dealing with arithmetic. We're always trying to change the equation so it suits us, so it's easiest for us to solve. But thank you, stay safe, be kind to one another, and I'll see you next time.